how to install my own software. So I don't have APL2 at San Jose State, but I do have APL2 that I obtained through the academic initiative that IBM has. So I do have an APL2. I've got an APL2 for OS2 that I actually bought, which is pretty old, and I have an APL2 for Linux that I got through the IBM academic initiative.
Got it.
And those are the two that I'm using, and Dialog APL.
I
And
had a
Dialog APL2 almost seems like another language to me. It's kind of hard to make the switch.
to go into dialogue.
Yeah.
Well, you might want to look at QuadML because some of the things that drive me nuts about their approach are actually, in my point of view, fixed. If you go, I forget whether it's 2 or what the number is, you'll turn around the difference between monetic take and drop and what is it, right shoe.
Yeah, that's actually hasn't been a problem for me. It's things like a picture format. I thought I'd see if my tax program would work in Dialog APL. And immediately I hit on the fact that I'm using a bunch of picture format for formatting the output.
Oh, okay. I've never, my only use of APL2 was when I was trying to write my own APL, and I used it as a standard. But back then they had a limit on how much CPU time you could use before they turned it off. Yeah. And naturally, since I was doing a lot of testing, I managed to run out of it in about a month and a half.
Oh dear.
But it was never key to my understanding because Jim Brown had his own APL, very much like APL2 version. So I could turn to it, and then I forget who it was Roy Sykes. Somebody came to Applebug and gave us all these pointers to other APLs we could get. And so that's when I first got a copy of Dialog APL.
Yeah, that was how I got my first copy of Dialog APL, actually.
Hey, Adam?
Yes.
Adam, doesn't Dialog have a package for people who want to move from APL2 to or APL 2000 to Dialog?
Does Dialog APL even have packages at all? But do we?
Or a system?
I mean, there. I don't know of anything off the shelf to help from APL2. We only have something for APLX, which is very much an APL2 clone. They're almost identical. APL2 has complex number support. APLX doesn't. APLX has some object orientation stuff that APL2 doesn't have. But I think that's about it. And we do have some help for that. But again, other than that detail of monetic up arrow versus monetic right shoe, there's very little in which Dialog APL isn't just a superset of APL2. There's some system functions that are different. Arrow trapping works a bit differently. Anyway, so it is now the hour. And this is a bit of a special episode of the APL Campfire because Curtis has been nice in helping arrange this. Personally, I neither knew Paul nor did I even know about Paul. So he's been absolutely instrumental in having in arranging this. And I don't know, Curtis, do you want to give an introduction before we tell Paul to just start talking, or?
I'd like to say as little as I absolutely have to. I think we've got a nice introduction from Paul in the announcement that I think everybody has seen. And so I'd rather let everybody hear Paul speak about his career and APL.
Okay, well.
Well, I do want to welcome everybody on behalf of the APL Bay Area Users Group. And perhaps I should explain a little bit of why we're doing this as a joint meeting with the APL Bay Area Users Group, which is the ACM, Association for Computing Machinery, requirement that its local chapters have at least 2 meetings, 2 real meetings of the group every year. And so I figured, okay, we can just kind of pile on to the APL Campfire and call this an APL bug meeting. So that's
Fine,
why we're calling it an APL bug meeting.
Okay, so with that, Paul, do you want to start at least by telling us a little bit about who you are and what you've been doing over the years?
Yeah, I'd be happy to. First of all, I don't want anybody to feel they need to make any apologies for not knowing who the hell I am. When I was going through writing things up, I realized that unless you worked with particular APL teams, that was extremely likely. I first learned APL at Trinity University. By the way, that reminds me to say that there's a lot of little hints for side stories in my self write-up, and I encourage people to ask questions because I don't want to get off on side tracks without some sense that there's interest in those side tracks. So, because I know me, and I very much model my human behavior on something Mark Twain is famous for having saying, if you want me to talk now, I can talk for hours. If I've got to do a 5-minute presentation, I'll need a month or so to prepare. It's very easy me start wandering off in my memory and just keep yakking. Basically, I had gotten a psychology degree. Actually, I hadn't quite gotten a psychology degree when I started learning APL. Trinity was quite a small school. I think while I was teaching there, we managed to go over 2,000 students. And so we had a big celebration for that fact. Joey Tuttle loved the story I had about what happened as a consequence of that fact, in that my first professional actually paid to do work as opposed to doing something as a student was taking a program that Princeton had written and helping Trinity decide which students to provide admission to based on their probability of being successful. And this program divided the universe up into men, women, and engineers. It turned out serendipitously that the university computer center had 3 useful floors and a basement where things like elevator control and stuff were, but there were no bathrooms on the first floor. So there were only 3 doors in the basement, men, women, and engineers. So we gave the engineers no end of grief over this amusing fact that clearly the people who had set up the basement understood this logical division of human beings. And since Joey had a degree in engineering, he just found that just terribly amusing. I don't know whether, I haven't watched all the old things, but I don't know whether Joey has been a speaker yet. But if you want to hear just uproarious war stories, you don't come to somebody like me. You don't even come to somebody like Ken. You come to Joey because I don't know that he deliberately acquires them, or he chooses jobs based on being able to get them, but the end result is that he has a lot. Anyway, so you got to give the context to this. I had left my philosophy degree in, what was this? 3, 4, 4, 5. I basically left it in 1965 and switched to a psychology degree as my plan of attack in 1966, and then ran out of funds. So unlike one of the speakers I listened to who managed to get himself to England to avoid the draft, when I no longer felt I could afford to continue Uncle Sam graciously offered me a free trip to Vietnam. And when I got back, of course, now I had the GI Bill, so my way was paved for the rest of my education. And initially had to take 2 courses. Back then, I don't know whether that's still the practice, but some courses were worth 3 hours and some courses were worth 4. I think it had to do with whether it was a lab associated. And there was the requirement that we have 6 hours of computing as part of the psychology degree. Well, the intro computing science was pretty straightforward, and like many schools, we didn't have a formal program at Trinity in 1968 when I got back. Some departments like physics and stuff were teaching their own classes. So was psychology, but there was no formal department. And as part of the computer science, a lot of the intro courses were actually taught by people who were employees of the computer center. So the first course was quite easy, a little bit of Fortran. Then when he ran out of things to say there, he started in with a little bit of PL1. Unfortunately for him, he was reading the manual as he taught it, and myself and one other person were the kind of people that were so excited by this new technology that we were clearly reading faster than he was. So he was constantly making statements, and we'd go, "Excuse me, no, that's not how PL1 works," or "Excuse me, that's not a constraint. You haven't read the manual yet." And so naturally, as a pain in the ass student, I made quite a hit of myself, but I enjoyed the class. And then the second course that we had to take was assembler programming, which was actually taught by one of the psychology professors. At this had attached to it a line printer and a card reader and a tape drive and 2 2311 disk drives, which I don't know whether they could actually hold. I don't really remember whether it was multiple megabytes or not, but they were pretty small devices in terms of storage. But because of the architecture of that particular machine, it was quite fast for scientific work. In fact, it had its own specialized PL1 compiler and so forth. But my project that I took on, since he taught graduate students too, he tended to teach all courses if they were graduate students. So he had to have a principal project, and I took over a project which was basically you set your own goals. And my goal was to take over control. That is, if you called me, I'd start stepping your program and showing you all the operand storage values in the storage locations referred to by instructions, and then actually executing the instruction. As a consequence, I had to learn a great deal about all the transfer control things like branch and conditional branch and all this kind of stuff, because I couldn't stick them in line and work or I'd lose control of the program. Furthermore, they tended to reference things relative to their location in space. And so the trick of moving the instruction in line wouldn't work if you were doing things like that. So I learned a great deal. And then one evening as a computer operator, which by the way, I should say, I would have never passed that course if I hadn't managed to get myself a job as a computer operator, because these were the days when the way you got work done was you key punched some cards, you handed them in the window, and then you waited around patiently for the operator to run your job and hand you back your printout and cards. As evening computer operator, my work had a fairly high privilege in terms of turnaround time. One night, one of the things that we did back in those days, the reason this thing was cheap although it was so fast, was it didn't have the storage to storage instructions, which include, for those of you who don't know the IBM architecture, included the packed decimal arithmetic, and COBOL depends extensively on packed decimal work. So all you had for operating system was Fortran, a non-macro assembler. I've never seen anything since, but it was an assembler, right, macros, and a linkage editor, which knew how to link that Fortran room together. So if anybody wanted to do business work, we had to reboot the machine into DOS. I noticed in one of the previous sessions, people got a little confused by that term. There have been in my career 2 definitions of the term DOS. There's a very early operating system via IBM, which stood for disk operating system, and then there's the DOS that came out in the early 80s, which was the operating system for the PC. Anyway, back then the way had been that you had this small deck that you booted. That's because there were 2 operating systems below DOS in complexity. There was one called Basic Operating System, which basically consisted of a deck of cards. So the entire operating system was being loaded on 100 or 200 cards. And then there was, if you were doing certain kind of bills and stuff and we're going to do a lot of work, there was TOS, tape operating system. So DOS was this relatively big step up, but about the time frame I got there, we also started experimenting with OS. And unlike the other operating systems from IBM, this one was thoroughly documented. I vividly remember all these manuals that had the operating system compared to Alice in Wonderland and who the master scheduler was and all this kind of nonsense. So they had a Disneyland kind of approach to graphics to describe how things work. But because of my experience with writing Stepney, I was able to answer a question about how you preserved the condition code and then restored it in the load PSW. So on that basis, I was able to apply for and get a full-time job in the computer center, and thus by that summer, got myself one of these choice plums of being able to teach intro computer science programs to students as a way of enhancing my personal revenue. And then the next year, which would have been my senior year, we were learning this. I don't even know what IBM was planning to call it, but we had a beta release. It had BASIC and PL1 in it. And I was tasked by the computer center to find out if this subroutine library that they had access to could be converted from Fortran to PL1. Unfortunately, the PL1 in this little terminal system was only 3 character names. And since I'd also learned PL1 in my junior year, I quickly discovered that many of the really useful business functions weren't available either. So I don't really remember whether the fellow was still a salesman or he was a former salesman, but this IBM representative came to us and said, you really ought to take a look at APL. And his major selling point was performance. If you ran this terminal system that IBM was selling to us or I guess offering to us as a beta, I don't think we were yet paying for it. You entered an expression and you pressed return, and a second or two later, the answer came out and the terminal returned, and a second or two later, the keyboard unlocked. Back then, 2741s were things that required 4 he-men to push across a floor. If you've never seen 2741 from the 1960s, it's a thing to behold. It weighs roughly what a small car does. And as I think other than the typewriter on top, I think it basically had the configuration of a box that was about not quite 3 feet cube. Don't really know the exact dimensions. Anyway, the APL system, he typed an expression, pressed return. The answer seemed essentially immediate. The carriage return came back after the output, and the keyboard unlock was essentially immediate. And that was enough to convince myself and a couple of other people in the computer center that we really ought to look further at this APL. So he began teaching us a bit of APL. And as the person assigned not to train mathematicians and engineers, because those departments were doing that themselves, I was looking for ways of talking about programming that seemed things that somebody in business school might be interested in. So we'd already focused on turning a name around at the comma. And I vividly remember going into the finals thing and writing the, what do you call it, extra credit question on the board, which was, here's this expression of open paren name, iota, comma, close paren, pivot, or I forget the exact expression, but I was terribly impressed by it. Had been very tedious to do in Fortran because you had to put the characters into words. It had been substantially less tedious in PL1, but still several lines of code. And now here was this one-liner in APL for expressing the same concept. So the next semester, I believe it was right after that. It was either right after that or it may have been that summer of, let's see, CX 969, 70. May have been the summer session of 70 when a fellow by the name of John Hallen was hired by Trinity to create the department, and he chose the name Computing and Information Science, which at the time I had no familiarity with the notion of information science, but serendipitously was working as a consultant and then programmer for the university library to get all of its data onto catalog cards printed and searching a database. So I was familiar with some of the notions, just not the ones he was talking about. So basically on his arrival, shortly thereafter, I joined the new Computing and Information Science department, became a full-time instructor. And the summer after I graduated in 70 and in 71, that summer I offered what John and I thought was going to be an internals course in APL. But the computer center was concerned that this was too big a logic breach, that students might learn too much about how things work, and they were afraid people were going to attack the integrity of the system if they knew too much about how things work. So in fact, what we ended up doing was learning as much as we could about APL, not by looking at how it was written, but by looking at how it worked. And the first several things we wrote were the kind of things where the student would write tests where you'd simply return the error that would otherwise be returned if the shape of the arguments, the data type of the arguments, whatever that was inappropriate. But at its core, you could actually use the primitive. So you could use plus or minus or whatever as the primitive. It's just it was unacceptable to ever get any errors other than what I'll call the gotcha errors, because this is pre-trapping days. So you you didn't have to go looking to whether there was any non-zero numbers being divided by any zero numbers. But other than that, you weren't to get errors. And again, this is this is early days. This is XM6. We'd actually gotten to look at it pre-XM6 for a couple months before we'd actually began paying for the then released XM6. And so there was no error handling, there was no execute, there was no quad effects. So, sorry. If I give myself too many asides, I start losing my train of thought. Oh, yeah. The kind of tests you had to make back then were things like, well, it's quite easy to discover whether the row and rank, the shape and rank or meet requirements, because that's simply used row. But the data type, you typically had to do things like what's the value of one take zero reshape of an argument, and that's how you discover. You'd get back a blank if the data was character, and you'd get back a zero if the data was numeric. And if you compared the value to the floor of itself, you'd find out whether it contained any floating points. So it wasn't, you weren't depending on system functions to tell you this kind of thing. So we began to learn a fair amount of details, some of which I already know, and some of which was new even to me. But after a few weeks, even in a summer school thing, that was getting old. So we began to do, beyond the early tests, we began to do models where it wasn't so much that I tested by making sure your program caught all the errors that I could think of when I called it with a program with arguments. We started writing code, and the goal of that code, and I can't honestly say whether this was because APL Quad at the time was beginning to have these broken key problems or what, but I don't think so. We wanted to write non-iterating code. That is, you could simulate the behavior of the function, but you weren't supposed to use branch errors. You were supposed to actually come up with some expression that gave the same result. So after a week or two of doing that, it was getting harder and harder for people to think with how you'd go about writing it, and we got to dyadic transpose. And I confess, I was feeling a little over my head at trying to tackle dyadic transpose with roughly a year and a half, I guess, of experience using the language at that point. But for anybody who's been a teacher for any length of time, I had the luck at the time to have a professional student. I think this particular one had been working on his bachelor's degree for a little over 7 years. Gave me this eye and, oh, you sure you can't do that? And that was just the kick in the pants I needed to go back to the computer center and write my own thing, which I did succeed. And because when I just looked at it off the top of my head, I didn't see a way. Whereas there'd been easy ways to see the way to back then APL didn't have scan, but it played enough around with outer product to realize that you could get very nice masks out of the less than, greater than, less than or equal. And turns out less than and equal has a perfect mask for doing scan. You take the value and you do a whatever function you want, dot times against iota of the row of the vector, circle dot less than or equal iota row of the vector, and you've got the mask that makes the inner product give you scan. But this one wasn't easy, but it turned up again in later years. Early 2013, I think, but it may have been a little bit earlier than that. A fellow who subsequently joined Dialogue, I haven't been in touch with him for a couple of years, so I don't know if he's still there. But let's see, what was his name? Anyway, since I can't find his name real quick, I'll just say the fellow that wrote the APL in JavaScript was working on things, and he could wrap his head around transpose a la what you do in a spreadsheet where you change rows and columns, but he couldn't quite wrap his head around dyadic transpose, where you had the ability to move any dimension in any direction. And then even more generally, that if you put multiple dimensions into the same new dimension, you then have to get the main diagonal. That is, you have to take only the terms whose values match. So I drug up my copy of this thing I'd written back in college, and obviously he was quite bright. Nick, I believe is his name. Nick
Nikolov.
That's it. So he's obviously quite a bright fellow, because based on seeing my non-iterative dyadic transpose, he was able to figure it out and go away and write it without any further instruction. It was a very interesting character, because he was already started on the idea, but there were all kinds of things about APL he didn't understand. So, and some of them he just refused. He absolutely refused the notion that anybody would ever want a computing language that had something like quad CT in it. That no numerical analyst would ever use this nonsense, so go away. And rather than fight him on it, because I was more interested in testing out the concepts in his new language than I was in demanding that he get right to the perfect product. I went back in, and while I'm certainly no JavaScript expert, I could find all the functions the way he'd written them and add the necessary calculations to make the a quad CT that I provided work. Now, I don't want to take any great credit for having done that, because thanks to my time at IPSA, I still had a copy of Paul Berry's manual, and he'd done an excellent job of describing the various functions that are quad CT sensitive as to what exactly is the formula for doing those things. This is not only all the compares, it's ceiling, it's floor, it's iota and epsilon. And I could never find any rule that said whether identity was or wasn't. I think it's supposed to be, but I don't really know. Back when I had access to the code and was looking in the early days, the I-beam that was sort of the precursor for it was simply really a mask. You were simply turning off low order bits in floating point notation. It wasn't until years later when I learned about what was going on with the IBM PC that I began to understand what all the thing was about, because floating point arithmetic on the IBM mainframe did shifts 4 bits at a time when it was talking about floating point numbers. So the best granularity you could get was a 4-bit granularity for numbers, whereas numbers in IEEE format get to shift numbers around 1 bit at a time. And so there's not the sawtooth nature of the number system in the extreme conditions with lots of trailing digits. And so while that trick worked back in the IBM days, it didn't make sense in the IEEE days. Okay, I think I've wandered sufficiently off the farm. Sure, go ahead.
That version of NGN APL, that's Nick Nikolov's APL, which
Right.
has a session and has some things added, like I think Quad IO and so on, that weren't in the original NGN APL. Is that your site? Is that your code?
Yes, that's me.
Oh, I did. Okay, so then I have heard about you. So now I can
The
guess what PLJ stands for. You must have a middle initial.
PLJ stands for my initials.
Okay.
And I knew it as my initials, as there were 3 characters available visible to the public when you did a ports command. So everybody eventually became known by their initials. So I was PLJ, RDM was Roger Moore, RHL was Dick Lathwell, LMB was Larry Breed. You could tell who was online if you knew the initial codes.
And so Iverson must have been KEI, right?
Yes, precisely. And I should say that in terms of going to this, I can't really go to it from a perspective of people because I get all twisted around about which story to tell when. I tried that. I watched one of the presentations where the fellow did come from that point of view. But I'd get all confused. But the one that really stands out for me is Ken Iverson, because he's the first actual APLer that I ever got to know. I suspect, although I didn't realize it at the time, it was because we were actually getting serious about teaching all of our intro computer science classes with APL. And from the time that we got APL until I left, I'd say Ken visited Trinity at least twice a year. And I remember the humorous point to us all is he evidently shaved at least twice a year, because it was the running joke, which Ken will show up this time? Will it be the clean shaven Ken or the long beard Ken? So I got to know Ken quite well for those first 2 years of my association with APL. And then, which I should have known all the time, but I hadn't really prepared myself. Having joined the department before, I vividly remember graduating and the guy sitting next to me asked me what I was going to do next, by which he meant what kind of career was I going to go after. And I said, well, I don't know about you, but I'm going to go back and grade papers. I'm an instructor in the computer science department. Now, he probably would have been less impressed if he realized that the reason I was there at that age was only partly to do to myself and partly due to the fact that it had taken me 7 years to get through my degree because 2 of them had been in the U.S. Army. And one of them I'd pretty well flunked out when I decided to change majors from philosophy to psychology. Anyway, so I started looking for a job, and the 2 that I found that were of interest to me and seemed interested in me was one looking for a CAI coordinator. I think they were both looking for CAI coordinators. This was a big topic in universities at the time. This was 1972. And people were thinking about how they'd introduce computer science to their instructors for ways it could be used. And one of them was Dallas County Community College. And the other was Texas Christian University over in Fort Worth. So I'd already interviewed that week in Dallas County. And then I went over to Fort Worth and interviewed a couple days there. And that evening, something to my way of thinking really spectacular happened. We were having an ACM meeting as part of my, well, it didn't really have anything to do with my interview process, but it was simply being had that evening. And so I attended. And Aiden Falkoff, who I'd never met in my life, I think I'd seen pictures of him at that point, but that was my total knowledge of Aiden Falkoff, came up to me, took me aside and said, don't worry about this place. We've talked to Dallas County. They know how good you are. You're a shoo-in. Needless to say, it upped my feeling that night at that meeting enormously to know that someone at IBM was going out of their way to make sure I got that job in Dallas. This was a thing that was going on in community colleges at the time, which I only learned about a month or 2 later. There was a huge community college district in Florida, Miami-Dade, and then there was a large community college district in California. We eventually had a APL meeting that group hosted out in California. And so to get in with the in crowd, Dallas County decided to have APL be their programming approach, and that they too needed somebody to direct that activity. So I got hired to do that. And for the first, or at least 3 years, maybe slightly more, maybe 4, my job was to basically do things similar to what I'd done at Trinity, but there it was to undergraduates. Instructors in a community college district are by and large people working for their masters so that they can move on to a university. At least of the people I got to know, that was almost universally true. And so I had different approaches. The math and science people, I'd teach APL directly, and they'd find all kinds of interesting ways to bring computing into teaching their subject. The nature of distributing fractions amongst a matrix and doing things was the mathematicians. I don't really remember what the physicists were doing, but the people who really worked with mathematics did it. There were a few that had already learned another language and would give me some kind of grief. Like I vividly remembered one instructor quite adamantly wanting to know why the hell APL wasn't like a normal language and used an arrow instead of equal to indicate assignment. And I said, because it's sort of mathematically based, and A does not equal A plus 1. There's no universe in which that's ever been true. I don't think I was quite that rude about it, but I put her in her place. She recognized that there was a significant reason for doing things the way we'd done them. And slowly but surely that became the tool of use in sciences. Some of the scientists didn't want to do the work themselves. And again, this is still pre-execute. In fact, I think it's even pre-getting. We started with a copy of XM6. This was 72. And so I think we were running, they had gotten a Model 155, just like Trinity had done. And if you've never gone through a transition like that, it is impressive. Going from the Model 40 to the Model 155 was a 15-fold increase in speed. And of late, I've been very pleased to get 2 and 3 fold increases in speed. If you go through one of those, all of your assumptions about what matters and what's performative and what's a joke, they just evaporate overnight. You get new ones, but it changes your whole assumption about what can be thought of as working fast and what can't. So for the chemistry department, no, I think it was another department that I first wrote this thing that was a little, I'd learned enough about compilers. I actually taught a compiler construction course back at Trinity. That I knew about putting things on the stack and taking them off the stack and basically creating an order of evaluation that took parentheses and everything else into account. So I had this little program that would do that sort of simulated an execute in APL. It was terribly simplistic. I don't know whether I had more than one letter variable names and stuff for it, but it wasn't for writing complex programs. It was for taking a small set of values and running an equation and seeing what the answer was. And maybe I did that first for physics. All I know is there's a table in such a thing that says what's the, I forget the name of the term. There's a priority of traditional mathematics of plus and minus, and then multiply and divide, and then power, and then all name functions are at the highest. Proceed. Yeah, precedence. That's the word I'm looking for.
Precedence.
I apologize. I have never been good at names, and I'm now 77 years old, and somewhere in the last 5 or maybe as many as 10 years, I've managed to lose most of my nouns. So if at any point in this discussion, I look terribly stumped for a word, it's almost always a noun. I can tell you the concept, I can walk all around it, I can tell you what it looks like to be standing there looking at it, but I can't remember the damn word. Although occasionally, if I talk long enough, I'll remember the word. Anyway, so my memory is that chemistry had the attitude that almost all of their equations were this whole stuff over this whole stuff. So they wanted divide to have a different precedence than you did in normal mathematics. I was like, oh, no problem. Oh, we'll just stick a different number in here for divide. It doesn't have to have the same number as multiply, and boom, there you go. You've got chemistry precedent. So they got to where they were doing things. And then there was a whole class of teachers that weren't interested in APL from a programming point of view at all. They were interested in it as a tool. And this broke down into 2 classes. I remember a guy who taught, I'll call it weather science. I know for a fact he'd gotten a job as a weatherman at one of the local radio stations. I don't really know what they called what he was doing. But as part of his work, and again, this may have been him working on his next degree, he wanted a particular kind of statistic. And at this point in my life, my then wife was sick to death of doing the kind of grunt work that somebody well into an advanced degree in mathematics could get in Dallas, which was sit around over green and white paper and find mistakes in accounting reports. So she went to work for me and she wrote that program. She also wrote a program for a guy at another one of the colleges that was about scheduling trucks hither and yon. So somebody was teaching I forget, was it transportation or what the name of the underlying technology was claimed to be, but it was a scheduling program. And then the other group were people who simply wanted some assistance in testing. And I think that came first. So first came me putting together a little program where you could type a question, Q, quote, and then the question. And I think back then the term for it was distractor. They were picking up terms from psychology programs I'd taken myself. So there was the distractor and there was the answer. And you may well wonder, well, why would anybody do this? Well, they were worried about cheating. And if you had all your questions and all your answers, I could randomize the order the questions were asked, and I could randomize the order the answers were in. So the fact that you were sitting next to somebody in class didn't mean a hoot, because looking over it and finding out what answer he gave to the third question didn't help you at all, because the probability that you were sitting next to somebody with the same question sheet as you was essentially zero. And there was also a organization within the this approach to learning, which was looking for a more meaningful job within the organization. And it's about the time that I went to the Orange Coast thing, and we saw this, I believe the company was called Scantron. And this is basically a machine that you stick in a thing. And I don't really quite know how you load the format of the true answer sheet, but you load in the thing and it gives you back a piece of data that tells you which answer did they choose for each of the 20 or 30 questions that are on the test. So there's the questionnaire, and then there's the sheet, and you give the answers, and the answers are in a very regular rectangle. And then with a little computer program, you can easily turn that into knowing, okay, which test did they take? What are the answers? Score it. So everything, just other than somebody having to feed the machine to read the little sheets of paper that were the answer sheets, everything else after that is fully automated. So the instructor has to write the questions. The creation of multiple tests, while initially done by instructors, quickly then becomes something that the testing center does. It simply produces 4 or 5 versions of the test based on how many tables they have in that particular college to give out, so that people sitting next to each other aren't getting the same test. And then when the student turns back in the paper, they scan it and they can send off the scores that students are having. This was also part of a whole thing that was becoming a big deal in community colleges at the time, which was called continuous entry. So as is advertised to us, any student could come to us at any time and join any class. And then they'd simply take it until they'd learn the whole class. Now, personally, as an instructor, I thought this was a bloody nightmare, but nobody asked my opinion. I wasn't teaching students. And because I always think of this stuff as following from each other, but clearly there were courses that didn't have to do things that way. And anybody who could participate, that it was a feather in your cap from the organization's point of view to be participating in that. It was support for them in terms of they could make use of the testing center to give all their tests. They didn't have to have sessions in their schedule for when tests were given. Students went and took tests of their own volition. So those were the kind of things that were done. The one, there were probably several, but the one really interesting APL thing I did in that thing I've lost. When I left Dallas County and went to IPSA, Eric Iverson, who became my boss, had a strict rule. I don't remember whether it was, I don't think it was more than 10, but I don't know the exact number of workspaces. I had a tape that must have had well over 100 workspaces on it, because my 8 years at Dallas, I'd accumulated all kinds of cute ideas, but he had a firm rule. I think he was afraid people were trying to steal work that wasn't their own. And I suppose in the strictest technical sense, that could have been said true of me, because some of that stuff I hadn't written, some of it had been written by my former wife, some of it I'd gotten from Orange Coast Community College, which they had shared. I mean, I took symbolic logic, and yet Orange Coast had this beautiful little workspace where you could do proofs by using the shoes and stuff and doing symbolic logic things. And it was quite impressive how they turned it out. I never did sit down and learn how the hell it worked, but it was the thing that I would have liked in a little memorabilia cabinet somewhere, but that wasn't important enough to me to keep. And then after I'd been there about 4.5 years, the district was growing from 4 campuses, which is what it had just become when I landed there. I had what was for me the awesome new experience, because I'd been going to school and then teaching at a school that had been in business for 100 years. A school that was actually building itself the day I arrived. They were hiring deans, they were hiring a president, they were hiring teachers, they were hiring directors and so forth. And now, after about 4 years there, they were completing the cycle. The intention was to ring Dallas County with 7 community colleges. And so they were going from 4 colleges, I think, to 6 when I stopped being CAI coordinator, and then eventually 7 a year or so later. So I was asked to take over the system programmer position. The previous guy had a good sense of business, but not a very good sense of learning operating systems. And also, I believe my boss wanted to expand the role, although he never actually came out and said it. I was the one that proposed it to him. So initially, we focused on getting better hardware. We went from typewriters to, I'm going to say 2641A, but I'm not actually certain. This was an HP device, absolutely beautiful. And we bought well over 150, but I don't know the actual number. It was the biggest sale HP had made in ages. They had this beautiful APL graph, including the fact that if you started overstriking letters, if I know it worked for OUT, which was the original overstrike, and a little OUT came up on the screen, but it also knew about lots of the other overstrikes, including they'd even learned the dark immoral side of APL. So they knew that if you struck a, geez, what are some of those?
There were some handy ones, like you could overstrike an F and an L to make an E.
That's the one I was just about to say. Very good. You overstrike the L and the F, you get an E. Yeah, well, those work. Those work in the HP terminal. It knew about the dark immoral side. That's the comment in the code for anybody who doesn't know. And also, when I say the comment in the code, when I'd looked at the code, when I'd read the code, and still again for the years I was at IPSA, it was really all just cards. Yeah, we were now typing in on terminals, and yeah, we're now keeping it in on files instead of drawers with 2,000 cards, 2 or 3,000 cards in them. It was all online. But because we were submitting jobs to IBM JCL, and since JCL was based on cards, the last 8 columns were reserved for having numbers in them. So if you, in the event you drop them, you could sort them and turn them back into the correct order. But IPSA and probably several other organizations had begun this habit of putting initials. So since we all had 3-letter codes, our 3-letter codes. So you could look down through it and know, oh, Roger wrote this. Oh, Dick wrote this. So you didn't have to guess who was the author of the lines. You could read it there in the code. Sorry, that's the problem I have. I get off on a sidetrack. So I'm still back in Dallas. So in addition to doing that, then we decided that the problems they were having was all based on there being absolutely no security running COBOL programs in, I forget the name of their time sharing service as opposed to APL. And so I proposed, and my boss agreed, that we'd try to do some of our business computing in APL. So that actually increased the number of these 2641As we purchased, because we bought them not merely for students, we also bought them for the accounting department, for the registrar, and then we could pick up those student machines and make them part of the registration process. So one of my jobs then became to teach the COBOL programmers this new thing called APL. And it turns out a few of them had actually heard about stuff because I'd written simple little programs to, I don't know what they were for, but it was this little line at a time. You took in about 4 or 5 numbers and you just kept entering data, and then you produced reports about some activity that was going on. I don't remember what. And they were the kind of thinking people who'd actually gone and interviewed people and found out that not only the registrar, but the business manager really loved the system. But the people in charge of making decisions about what registration were going to look like had become very enamored of fill in the blank screens. But it turned out the 2641A helped us there as well. You could put up a little mask that created fields. It wasn't until, I don't think I ever used the fill in the blank. What is it, AP 124? That's for the 3270s. It wasn't until I actually used it at IPSA that I realized that the 3270s were quite deficient compared to something like the HP terminal. Every control character that you sent to it constituted a position on the screen. So you couldn't do something like label, no space, fill in the blank space. It had to be label at least 1 character space, because you had to say that that field was starting. So the character that said a field was starting was a character on the screen, even though you couldn't see it in the 3270 technology, whereas that wasn't true of the HP. But from a human being looking at what was going on at the HP terminal, it looked very much like what was going on at the 3270 type screens. And then instead of pressing enter, you pressed the send key. So you were in block mode on that terminal, and nothing was transmitted until you pressed send, and then all the fields got sent. So people really got into it. One fellow pointed out that it was wasteful to bother to calculate. I had put together a little function that would build a screen for them, but it was wasteful to do that. It used up more CPU time. So he was saving it, and that became the way to do things. And every once in a while, somebody who's a new student shows you something that you go, I should have thought of that. I've got all this reputation for looking at performance. Why didn't I think of the fact that we didn't have to? We just put that thing in a variable and send it when that screen started. But the thing that they were absolutely adamant about was the if then else, do while, so forth. And I confess I'd been a convert for some time. Back in these days, you didn't have text editors. So APL gave me this opportunity for writing a simple loop that gathered together text, and then another program where I could make changes to the text by saying, find this string and replace it with this string, that kind of thing. But it had, for years, had a bug that I couldn't quite find. And shortly after moving to Dallas, I attended my first share meeting and heard this lecture on, it wasn't the title of Dijkstra's Go To Considered Harmful, but it was basically pitching, here are the control structures you should use in a properly formed program. So since they were adamant that this was the way we should go, I decided to try my hand at writing a compiler. Well, here's Davin Church. Yes, I still have the staple code too. Basically, it was a compiler that you used if, do while, or do until, and I think it was select then case. I believe that was the way it was, but I'd hardly ever used case statements in APL. But I definitely used do whiles, and I definitely used if then else. And the compiler itself was written using the thing. And then after I'd had it going for a while, I decided to test it. It's about 20, 25 lines long. And I was thinking, well, there's all these big compares, the first n columns to see whether they have a branch and so forth, and clean it up and then calculate where the branches should be. And so I figured all that work might be using up some of the reason why trying to compile a whole workspace actually took a noticeable amount of computing to do. So I'd read about the ways to get timers on each line, and I did that, only to discover all of my great work was essentially of no consequence at all. All of the CPU time was used up in the quad CR to get the definition of the function, and the quad FX to recreate it. There were only two expensive functions in that whole 25, 30 lines of code. All the tests of all the things, the depths, and not just the depths, I corrected, because I learned, I don't remember whether it was right around that or whether I had this knowledge, that APL was stupid enough to actually take up a small amount of computing. If you branched to something and there were 3 comment lines, it would actually say, oh, here we are on line 27. Oh, it's a comment, fall through to line 28. So not a huge amount of computing, but non-zero. So I actually spent the time to figure out where the branch should really go, not to the else or in statement, but to the statement after the else or after the end of. And so I was thinking that surely in all that wish-wash that I was doing there'd be some cost, but no, I don't remember the numbers, but it was well north of 95%. I think it was either 97 or 98% of all the CPU time consumed there. If you could take the quad CR and quad FX out of the equation, no one would ever notice that that thing was running. Because I
So,
also,
how does this actually work? You would write your functions using these control words that weren't recognized, and then you would compile them?
that's right. You just compile you could compile a particular function. I think while the published name of the thing was staple, structured APL extensions, the actual verb in a person's workspace was delta. Now, this was based on previous learning with STSC APL, because long before there were all the quad names, there was delta WS and delta FD. So most of the functionality that IBM introduced at Toronto APL with quad names had already existed in APL Plus for, I don't know, almost a decade. Not all of it. I remember a pre-quad FD thing where we couldn't create functions. But by the time I was writing this kind of stuff, we had the version of APL that had it.
So how did it even look? You would just use those words and those would
You
be like
just use those
reserved?
words. You would just use those words. And some of them are actually functions in the workspace that came along with the compiler. So the if was a verb, what we call verbs today. I like that technology. I've really become enamored of the whole iris and think around J, but we called them functions then. But there are no words in the compiler for indif, do, and in case, or but maybe it's case. Those were simply comments. Those were simply turned into comments. Whereas is there a way I can do a presentation here?
Yeah, of
I
course.
don't.
And at least if you're on a Windows computer, you can press Alt S to share your screen.
No, I don't even. My children own Windows computers, but I only own Android.
Okay, so if then
Oh,
there
here
should
we
be some
go.
menu you can press a green button, share screen.
There's the green button that says share.
Yep.
Yes. So let me first go find a copy of it. I'm my avid user of Google Tools. So go to code, go to APL Campfire, go to staple. Okay, so I've got staple up. And now
You will get a choice between sharing a particular window and your whole screen. So if there are other windows popping up, you might want to share the whole screen. Otherwise, just that window.
I think I'll just share the whole window. That'll make it easier. I can figure out which one that is. Screen, there it is. Okay, so back here. So here we are. Here's staple.
I still can't see it, but
Oh, can
your
anybody see it, or if I still need to do something?
your video went away, but I can't see your screen. You might need to give permission of some sort. I don't know. No.
I've done presentations before. I'm not quite sure what problem I'm having right now. It's just that it's been so long since I did it. Geez, I don't even see the screen that is. Oh, there's the video. Okay, I've got you back. Do you see me now?
Yeah, we can see your face, but not your screen being shown.
Share. Share my screen.
No, when you
And
do
did I go away again?
yeah, that just means your video turned off, but you didn't actually get to share anything.
Oh. Well, Oh, wait a minute, maybe. Okay, I see where I can see the share.
Have you tried both sharing
Maybe,
the window and the
maybe
whole
if I
screen?
just shared Google, maybe if I just shared document.
Nope. We just lose your video feed, that's all.
I really feel like an idiot right now. What am I doing wrong?
Well, who says you're doing something wrong? Maybe the programs are doing something wrong.
Well, that's definitely a possibility. Something I've learned increasingly in the last few years as a retiree, you get to deal with things I probably would have ignored. And when websites just do not work right, and I'm like, I know computers inside out. How does some poor schmoo that doesn't understand any of this get any work done? Let's see if I went to Google Drive. Do you see that?
You just lose your video feed.
Oh, no. Am I back now?
Yes, you are. That's too bad.
Well,
You'll have to describe what it looks like.
It may not work at all, but what the hell? There's always another way.
So the code
Let's
that you have the stable code running, you're saying?
I don't ever run it anymore, and I don't have access to an APL where it's
Oh, so
installed.
you just have a
I could
picture
show-
of it.
I could show you the code.
Ah, so
And I could certainly share it. I have a whole website where I share a ton of things. So sharing one more thing on that thing is no problem at all. You go to PLJ541 at github.io and then /tools with a capital T. There's a whole slew of things that I share with everybody under the sun.
right.
Uh,
You should put that available for people in there.
including the latest version that I've shared with people, which is probably 2 or 3 years old now, of the APL on. Here we go.
So are you adding a thing to it or?
No, I'm trying a trick and not thinking straight fast enough. Here we go. Download. Only time will tell us whether this is any good. Can anybody see this?
Yeah, kind of. But you have to move it. It's off center, so we could actually see
That's
it.
off center.
Well, it's off center compared to your camera on your whatever device you're using.
Yeah.
If you hold it up again,
Well, first of all, I want to get the keyboard out of the way because that's consuming way too much. Okay, here we go. Okay, so
now that can be pretty much seen.
this is the version I'd work on. It is not the version people would get. Like Leslie Goldsmith, I would meet in a few years. Actually, I met him during this time frame, but got to really work with him in a few years. code that you wanted to do that wanted to work on functions needed to mess with itself before it was released to the public. Otherwise, all the names would mask the names in your workspace. So I wrote it like this so I could read it, but the actual version had delta underline 99, delta underline 98, so forth. In other words, you send it through a hider. But anyway, this code takes the quads. First, it sets up some arguments. Then it takes each code as a method in the loop of a quad CR of it.
Yep, you can see that.
Figures out, first of all, cleans up the code. So if there are any branch, it makes the assumption that people aren't writing their own branches.
Only using control structures with this.
So this is for COBOL programmers who were quite pleased with that rule because they hated the idea of writing their own branches. So it finds the branches, takes them and the number that follows them and so forth, and jams the code back up against the left-hand margin. Then it looks for these control structure words that it's created early on in the program, the if, do while, do until, so forth. It looks for those, figures out the nesting levels, figures out the open and close on each one. This is one of those things that you start with a simple concept like I'd already reached of on a vector, find the nesting level of things within parentheses or things within quotes. Okay, that's simple enough. Now take that same concept and apply it against a matrix, and you found various words and do the same kind of calculation based on which line they're in. Now, once you've discovered the nesting levels to each, find out if there's an error in nesting. That is, find out if you come back to normal at the end of the equation. If you do, fine. If you don't, report an error and don't try to compile the bloody thing. Then calculate where the branches need to be. So the if now gets a branch in front of it. The nature of the ifs and so forth aren't the kind of things people were writing to go with APL functions at the time. They're the kind of things that work like if in programs that do use control structures. That is, the if doesn't do something if you do it, it does if you don't. If the condition is met on the right, then you fall through. You only branch to the else clause or the end if clause if the condition isn't true. The branch that you'll construct on the else clause is unconditional. And then, as I said before, if you've got a couple of nested ifs, the branches away from the else go past the last end if in that nest so that you don't bother to jump to lines that don't do anything. And then when you've got everything calculated out, you do this quad fx and then you loop back through, because the expression you give it the right-hand argument has two things in it. It has the names of the function you want to work with, and if it's got a quad in the name, that means display the output while you're compiling. So you can either do a compile of everything just to get it clean. You don't want to read what it looks like right now. And if the list of verbs given is empty, then that means compile everything in the workspace. So quote, quote is compile everything in the workspace, and I don't want to see the output. Quote, quad, quote is compile everything in the workspace, and I want to see. I'm going to print this out. This is going to be the listing I work from. And just as staple uses staple, and therefore has all the indentures that is provided by the compiler, so does all the code that you write.
Are you going to make this available online somewhere?
Oh,
we
sure.
can-
If people are interested, I'll make it available on my website. And I can give you and Curtis a link so that you'll be sure to know how to announce it to where people would look.
It's so interesting. You speak about this right now, just today. Thursday, I was live at the APL Germany spring meetup, and there was somebody there called Jacob Brickman. I don't know if you ever heard about him. And he was talking about something extremely similar, a compiler for APL control structures for those flavors of APL that do not support control structures like APL2. And he had written something like this, and it's and funny enough, also written the same kind of style of using itself. It can
Right.
compile itself, and yeah, with optimizations and testing and making sure that you don't have mistakes in the nesting and so on. So
Yeah, exactly. It's a relatively straightforward program once you've grokked the concept that what you're really looking for is a nesting level, and that informs you of where you're going to branch to.
it's just interesting. The first time I ever heard about automating this in APL, and I hear about it twice within a couple of days. So.
Well, for me, it was one of my next major introductions. I forget which APL. Oh, I know which one it was. It was Ottawa APL. Is where I'd seen Roger Moore a few times, but never gotten to meet him. And somebody was doing a presentation on such an idea, but he had all kinds of strange little ways that he accomplished it. And I hadn't made a paper, but I basically stood up and asked the question, well, why don't you simply write a compiler that does that? Oh, well, that's not possible, or that'd be too complicated. I don't remember the answer, but it basically dismissed me out of hand. And Roger Moore came over and said, can I see what you've done? And I wouldn't describe my relationship with Roger Moore as a close personal relationship, but we chatted from time to time about one thing and another. And so I was used to his style of asking questions and enjoyed working with him. But that's when I first got to meet him. Okay, so that I think is pretty much a statement about my experience. Where am I in time, or am I keeping everybody well past lunch?
Well, it's so fascinating for me that I'm happy to hear more. Usually these things run for an hour, but that's long past, so don't worry about
Oh,
it.
long past. Okay. Oh, so it is. It's about half hour over an hour.
It's fine. It has happened that we had an episode that took 2 hours also. So if people want to leave, they're welcome to. It's being recorded.
It's being recorded, and I've enjoyed that approach. I did not know about this early on, and have watched the Jim Brown one, and then I worked with the fellow in the last one I watched. He's since made a name for himself in doing forensic analysis in APL.
Oh, yes, the DNA view.
Yes. But if memory serves, he's the guy that worked with me on the sax team to fix Quad Trap.
That's Charles Brenner.
Charles Brenner. Right. Thank you. Curtis had just put it up on the screen. If I look down frequently, I find the answer right in front of me there. Okay, so the one negative side of this effort with getting everything on APL is some of these people didn't appreciate that they couldn't be particularly sloppy, and we kind of swamped the system. So we got a bit of a bloody nose trying to, everything else was working fine, but registration got a bit of a bloody nose. And as a consequence, we got an Amdahl V6, which is, in case anybody, again, this wasn't quite the Model 40 to 1 55 upgrade, but a 158 to an AMDAL V6 was a huge upgrade as well. Not quite 15x, but it was spectacular. And my boss, was a great computer center director, but his programming knowledge kind of ended with unit record equipment and doing sums a la columns in spreadsheets by taking the plug board and wiring together which columns you wanted sums on. Couldn't quite grasp the concept of queuing theory and the fact that the performance was egregiously bad didn't mean that we needed a processor that was 20 times faster because of the length of the queues. We needed one that got the work done at the arrival rate of students. Nevertheless, he was taking a lot of heat for a failure to provide him with an interesting solution. And I began looking for another job. And then a month or so after I had the job at IPSA, we had supper together, and he informed me that the very people who had been screaming the loudest, namely the accounting people, about us needing another machine upgrade, would not let him change the system from APL to 3270s for precisely the reason that I'd originally gotten into APL and precisely what I was trying to tell him about APL when we made that change initially, namely that we were sharing what then sounded like incredibly fast, a digital 56 KB line amongst the 20 or 30 terminals that existed on each campus. So I think by then it was frequency division multiplexer, but I can't remember the detail. And when they tried to go back to 3270s, they were sharing one 9600 baud line with 5 or 6 3270 terminals. Now, the technology in terminals is you press enter and you've got an open line. And then if you've got a fast system, it responds to you on an open line. Whereas 3270 response is basically a whose turn is it? So there's a little controller sitting out at the campus. And when you press enter, it may take 1 or 2 seconds before it's your turn to transmit. And then when the computer has the answer, it may take 1 or 2 seconds before the 3270 the 3705 can respond to your request because it has to get its turn in the chain. So the people in finance were absolutely adamant that they'd tried using these new software on 3270s again and said, oh, but it's so much slower than APL. So you win some, you lose some. Anyway, I went around looking for things and actually attended the Asilomar conference in '79. And because of my contract with I already had like all the administrators, we took the same not the summer, but we took many of the same holidays that the instructors took because the students took them. And I didn't feel right about agreeing to join IPSA in early January. So I didn't actually join until February 1 of 2008, 1980. Whereas unbeknownst to me, Ken was also negotiating with IPSA. And so actually he joined after I did, but he actually became an employee a month before I did. And so then I got to see Ken again, whereas I'd only seen him at conferences while I was Dallas. Twice a year at Trinity, only at conferences for the 8 years I was in Dallas. And then I don't really remember how frequently, but it was way more than twice a year as I began working at IPSA. And my time at IPSA broke down easily into 3 compartments. Initially, it was clear Eric wanted me for APs, I'd already written a first before APs. I'd learned at a share conference about a trick in the XM6 scheduler that was widely used and abused by the APL Plus techniques for doing all the file system work. It's called back6. So you have a piece of work where you want to give up the CPU, but you want to lock a workspace into memory so that it can send or receive something that's in its buffers. You did a back6 call, and what it did was literally back the PSW back 6 bytes so that the next time you woke up, you do the test again to see if it was done. I put a interface to Adabase, which was the database the computer center in Dallas was using, in there. And then when we did bought the 158, we decided we were going, I don't think it was SVS anymore. I think by then we were on MVS. So I'd gone DOS, MVT, SVS, and then MVS. And I'm sorry, I've done it again. I've gotten lost in the detail.
Okay.
Anyway, yeah, I'll just go back to, I'm going to work at IPSA, and part of what I think he wanted was my knowledge of MVS, which they were just leaving what they referred to as sharp DOS. Bob Bernecki had decided it was getting too complicated to write disk drivers and the machine check interrupt handler. So he decided that he didn't want to be the guy maintaining sharp DOS anymore. His machines got more and more complicated. That was Bob's point of view. I suspect from Eric's point of view, it had more to do with big customers like Morgan Stanley were on MVS and were wondering when in the hell could they run their APL on MVS, their copy of APL. And so in our conversation at Asilomar, which was basically my job interview, he asked a lot of questions about MVS, and I knew a lot of things. And then when I started there, I helped Lee Clayton, who was doing a lot of the internals work on getting to MVS. And then he had me write some APs. So my first one was called Pajam. That's because I'm a thoroughly modest programmer. And since I knew that TSIO actually stood for Tuttle Shively IO, I thought the Paul Jackson access method was a perfectly acceptable name for its replacement. And I learned an incredible amount. I thought I knew MVS when I started. There were 3 little booklets. I don't even remember what they were called. They were roughly the size of 3x5 cards. They came in tiny little binders, and every conceivable control structure in the entirety of MVS was documented in these 3 manuals. And I ended up using a substantial number of them. As also part of that work, I was working in Palo Alto, and I didn't think anything of it because I'd never been the kind of person that went into the machine room to figure out how things were doing. And I had made a subroutine that allowed me to grab the memory buffer of whichever system, whichever user I wanted to look at, and then APL functions that would extract the various values so that I could interrogate what was going on in that particular processor. And MVS had this incredibly powerful trapping mechanism in the machine code called eStay, which meant it didn't matter how severe the problem was you were having, I could capture it up to and including the operator had just said, cancel this bloody job, which would arise in situations like when you were asking for a tape or a disc to be mounted. The operator could say, I'm not mounting that bloody tape, cancel. To which the jam would respond, oh, that's an error so-and-so, which you look up in the table and find out the operator refused the request. What do you want to do next?
So you're literally trapping a human error, trapping a human action.
You could trap any action. There was no action. There was absolutely zero exceptions. The only way they could take control away from you was to press IPL on the machine and destroy everything that's going on. There was no action they could take to jam once it started that would bring it down, because all it would do is say, oh, report to the earth, asking what he wants to do next. All right, guys. Part of the love I have for many people, COVID has been horrible, but for me, it's brought two enormous things. One is contact with friends all over the world, because calls are no longer expensive, although people don't take the hint initially. Anyway, and then a lot of these kind of things. We've been having meetings from all over, including getting in touch with people I haven't been in touch with for years. I noticed earlier, I think Davin Church is on the call. He was one of the students that got trained in APL when we were converting Dallas County Community College from a COBOL architecture to an APL architecture. At least from the notes he's given and talks he's attended online, I believe he's made a career out of APL. So it's nice to know that training individuals had some success. Okay, let's get back to real time here. So he then had me formalize this and made it a separate little subroutine that every AP, Eric dictated that every AP would henceforth have this debugging tool in it so that you could sign on to this magic thread that was in every AP if you were a system programmer, and find out what was going on. This too also included crashes. In fact, my way for debugging certain things was to deliberately go in and patch an opcode error. So the thing would simply crash, and I'd look at the crash and find out the PSW and find out what was in the registers and figure out why the code wasn't working. And I wrote a few other auxiliary processors, and then when we ran out of that, he gave me my first APL internals. I'd done a lot of little hokey stuff at Dallas, but he gave me my first and actually only APL internals project, which was Character Thorn, which has been singularly unsuccessful in the rest of the world. I know Ken dropped it out of the dictionary. I don't know anybody other than IPSA and APL2 that provided the character left argument to Thorn.
That was what we started off at the very beginning with, right? The picture format for formatting.
Oh, do you have it in dialogue?
We don't, no. We
Oh,
don't.
okay. Anyway, so I wrote that, and Bob Bernecki, he and I occasionally had arguments about one thing and another, but he was a big fan of performance. And for those of you who don't know the internals of Quad FMT, it was very focused about getting an answer as quickly as possible. So it did formats one line at a time, which meant every format had to be interpreted before it could be applied to each column. Whereas I took the reverse approach and calculated how big the total result would be, got the memory set aside, and then started filling in the columns based on the format specifications in the left argument. So it was substantially faster than Quad FMT. So Bob put out a couple notes to internals pointing out that if they really wanted to improve their performance, they might consider getting rid of the, I don't know whether he actually used the words Quad FMT crap, but I know he and I shared a less than enthusiastic opinion for having Fortran bolted into the language.
It's both Fortran and COBOL, right? Yes.
You may be a little COBOL. I actually wrote a very COBOL-esque one, and a couple of IBM reps really pushing it. I remember at that same Asilomar conference, there was an IBM rep pushing mine. Aiden's approach took a different definition for every digit. And mine, I think I simply reserved 4 carats. So one meant there's a digit goes here. I think that was up caret. One meant you've got to start putting zeros here. One meant the previous digit, that thing to my left is the decimal point. And I can't remember what the fourth one is used for. Maybe I didn't even use 4. Anyway, which didn't have near the number of features that Aiden's had, but I could definitely assert that I looked through there's a machine instruction that takes decimal and formats it. I can't remember what it's called, but I could assert with confidence that there was no formatting you could do with no COBOL formatting you couldn't do. And even some of the things that COBOL didn't support, but were supported by the machine instruction, were doable. So it seemed to me that the only reason people ever wanted to use this crap was that they were producing business reports and they needed to ensure commas in the middle of things and all that kind of stuff. So how far apart commas were, you didn't put in something that said put them in every 3. You put them in wherever you bloody well wanted, and that's where the commas went. And if the switch hadn't been turned on that you got significance, they'd disappear and so forth. I mean, you got all the same properties that business reporters wanted. And because unlike the other formatter, the other left argument for Thorn allowed for 0 as the width, meaning you figure it out, I was always working with a known field width. So that's why I could do the trick of putting the values directly in a column, because I knew how wide the column was. If you've got a 0 in there, you don't know how wide the column is until you formatted all the bloody numbers. And then you go back and figure out how wide that field is if you're going to maintain the APL assumption that the decimal points must be aligned, which I noticed with some lack of enthusiasm, a number of APLs have begun to give up on as they get deeper and deeper into nested arrays, including the one I'm using today, which is J. people have begun to say, well, aligning decimal points isn't all that important. And they're right, but I still like the way output looked when you made an effort to align decimal points. So that's the first piece of my career. That went on about 3 years, maybe 4. I think it's more like 3. And then Hitachi, who had purchased our what came to be known as SAM, but it didn't have that name until we created SAX. SAX stands for Sharp APL Unix, and what had previously been called Sharp APL became SAM shortly after, to distinguish whether you were talking about the version that ran on the mainframe or the version that ran on Unix. And so I was in charge of that. I had some interesting issues there. Here I am with a name again. He's done all kinds of languages since.
Arthur Whitney.
Arthur Whitney. Believe it's Arthur, that he was living in Australia at the time, and he offered us his vision of APL. And it had some interesting properties, including some that are in the JavaScript version I have today. Namely, you could redefine the primitives because the primitives were in the domain of assignment as they are in the JavaScript APL. But I was no expert at C programming, but his style of writing code bothered me terribly. And I had a couple of APL experts, C experts working for me, and they actually coughed up blood at the idea of working with his code. So I undertook to get a relationship with STSC and get a copy of their Unix APL as the basis. Now, I may have been somewhat aware of the conflict up until that time, but I really became aware of it once I took on that role of the intermediary between IPSA and STSC. Some years back, we shared a code base, but there had to have been a falling out. I don't know when, and I don't know over what, but there were several IPSA people who cautioned me that I was doing a deal with the devil and that I'd best watch my back pocket. Later, I think STSC felt the same way when we started adding shared variables to their product, and Morgan Stanley decided that they liked our version of the Unix product better than STSC's, even though they'd already bought STSC's. So it caused a little bit of conflict hither and yon, but basically we worked together well. Got to know Bill Rutizer. I think his real first name is William. He'd written some really nice features in there that made some efforts to compile the language and make it execute a good deal faster, which had a huge impact on our implementation of both quad trap and on packages. On packages, we simply didn't have the capability to save functions that had been analyzed, because part of the analysis of the function was with reference to the environment in which they lived. And if you removed that environment, you made invalid the assumptions that were made in the signatures that were kept in the executable form. So Roland Pesch and I made the decision to do a visual representation of package rather than an internal representation of package. It's at times like this that you learn just exactly how strong the belief systems of various implementers are, and that Dodd decreed that no man should be able to read what was in a package. But we never once ran into a problem because of it. Yeah, I believe in one of the meetings that I talked to, you expressed the fact that you had worked on providing a text-based version. I don't know if it's just of save or what it's a text version of, save and load or save and copy, whatever. I've become very enamored of it. My first post-work project was to write my own APL in .NET, and I couldn't think of a good enough way to write an easily parsable input form. So what I did was end up doing the same sort of things that eventually I think Bob Smith did with NARS 2000. I wrote an XML version, which was highly easy to parse to get in functions and nouns. But then working with Nick, he'd obviously looked enough at dialogue that he was familiar with the brace notation, which I personally love. And only finally, and I can't take any credit for it, but finally, Jay has accepted that as a permissible way to write verbs, adverbs, and conjunctions as well. Unfortunately, they'd already given up braces for subscripting, so they had to do double braces to do the same notation. But other than that slightly offensive choice of characters, it has the same, well, it's not quite the same properties, because before they got there, they'd already cut off some of the things that I personally had been weighing against for years. The initial versions of APL, you basically have fruit salad. If you have a local, then it becomes the global to the guy you call. And while one can find justifiers for what neat kind of things you can do with that, and believe me, I've found and used them. When you come to debugging really big systems, it's really, really nice to be working with a function whose locals are locals, goddammit, not masking globals which themselves behave as if they were globals. Because the function you call has no way of knowing that he's not modifying the global, he's modifying the local.
Between lexical scoping and dynamic scoping, but both of them give over their values to subfunctions. If in the lexical case, the function, it's the subfunctions that you're defining yourself.
Well, I don't really know a lot of in-depth about dialogue, although I've used it to discover the definitions of some of the harder functions to define in my own work. The way he did it in JavaScript, everything about syntax analysis happens when the bloody thing is loaded. And in fact, if you were then to copy in another table of things, a new definition could come in for the function, but all the functions that were defined back when we had definition 1 will still work with definition 1, even though now the only definition you can see is definition 2. So he took it way further than Jay took it. And again, I was with him. I knew full well that his model was never going to give me any serious debugging tools. He can barely tell me what line blew up. He can't tell me where, and he can't show me the values of the variables at the point of blow up. So it's a bit of a nightmare to debug, but it's also impressive to load an interpreter from the web that you know everything you're receiving, everything, every byte you're receiving is source. The interpreter is in source. The workspace I'm loading are in source. And I've actually got a copy of the quad divide that Roger Huey gave me, which is itself source. And when you're running on a machine, today's machines are fast enough that I can run one of Joey's 50 by 50 quad divide matrices things and outperform an Amdahl V8 that I worked on in the early 80s on my platform, even though I know that it's all written in JavaScript, which all started at source, and the programs that I wrote are all started in source, and yet it runs like a bat out of hell, even though there's two levels of non-machine interpretation going on, which I know it's probably egotistical of me, but it really brings home the idea that I was arguing back in the Sachs days, that the constant worrying about machine code is a thing that's lost its value as machines get faster and faster, and we can focus on new and interesting functionality instead of worrying about 2 mics here and 3 mics there. But I'm quite certain there are still people who are worrying about the 2 mics here and there. Okay, so second phase was Sachs. That introduced an interesting part of my life, in that since I was in charge of Sachs and Ken was busy writing what he called direct definition, which they hadn't thought about using braces around it yet, although I don't know whether that was me who did that. I know I took some of those and turned it into braces, but it basically, I think it started out as 1, then a colon, and 2 definitions, where one side was monadic and one side was dyadic. And then at some god-awful point, they decided that they'd introduce what I think of as the Roy Sykes branch from hell, where you construct a vector and then you go to all the points specified by the vector in a kind of a case statement from hell loop.
What?
Yeah,
That was
you
a joke I came up with when I was a little kid. I said to my father, when you give a vector to branch, it should execute all those lines in order.
Well, it started out with Roy Sykes noting that incrementing a counter and testing it for whether to branch or not, and then using select or drop or whatever to cause the branch to occur or not occur, was more expensive than pre-calculating a vector that simply had the number of pointers to the label, and then perhaps a 0 at the end, or perhaps you fell off the end. I don't remember the details. As the first line of the function, and then dropping into a loop that only incremented and used subscripting to choose the next branch label. And I knowing whether this was Ken's bright idea or what, but there was an early version of J that just about made me vomit, where they introduced this generally so you could specify which which line you went to. So you could have this maze of lines being visited because every line went back to the choose point. And so you could put as wild a set of choices in your argument that said what lines to go to. And I thought, boy, this is where Jay is going. I don't want anything to do with it. And I literally didn't have much to do with it for more than a decade after that. And then the third phase was when I was no longer working in, well, I was still had SACs as a personal responsibility, but I then became head of the zoo. And my focus was on restoring customer confidence, because the previous administration had focused on a lot of very interesting research work, but they'd lost track of the fact that performance was still a heavy issue amongst a lot of our customers. And we actually came out with a release that substantially slowed down a whole bunch of operations. So we worked on taking some of that code out. We worked on improving the performance of the stuff we wanted to keep and so forth on the mainframe. On the SACS end, Ken would call me up and come up with some real doozies. The one I remember vividly was today he has both equal dot for local assignment and equal colon for global assignment. Back then, he was playing around with the notion of having assignment arrow, meaning, I forget whether that one was the global or the local, and space assignment being the other one. And I was very politely telling him no way in hell. And he wasn't having it, so he was explaining that nobody was ever right mind would ever put a space for that. And I said, well, that's not the issue about what they would do or what they wouldn't do. You're not changing syntax rules. You're changing the definition of words. And I won't have it. APL's got a real clear definition of words, and none of the symbols require or are harmed by having space around them. And you're going to introduce a symbol that means something different if it's got a space in front of it. And that makes space be significant in the formation of words. And it's not, and I won't allow it. I was very pleased when back in about, I don't know, 2015, somewhere after Microsoft had made my old APL Plus from SDSC useless because machines were no longer 32-bit, which would also run 16-bit software, which only then did I fully realize why the arrays couldn't be bigger than 2 byte. It's because the whole software base was 16-bit hardware. And 32-bit hardware would run 16-bit hardware, but 64-bit hardware will only run 32-bit instructions. It won't run 16-bit instructions. So you could no longer run SDSC APL. And so I started looking, and that's when I got really interested in J and was very pleased to find that the Roy Sykes branch stuff had gone away.
Interesting. And this is one of the things that bothered me in K. K puts lots of significance to a space next to things.
Well, it's probably where Ken got the idea. It doesn't sound like the kind of idea he thought up on his own, but he was an open listener and somebody probably suggested it, and he watered it around in his mind for a while and thought that is a pretty good idea.
Well, Ken probably doesn't have any influence on it, but Arthur Whitney is obviously the one that's designing this.
Well, that's what I'm saying. The flow probably came from Arthur to Ken. I know Ken was quite impressed with the very version of APL that I rejected as the source of SAC. I know that for a fact. I don't have to guess about that. The other thing, which I don't know where the source of it came from, and I forget what he was going to call the operator. He was going to, and there is a similar but much decreased operator in J, where instead of having things like quad CT, you have a variance operator.
Yeah.
And as they've done it in J, I'm fine with it. I like it. As that was proposed by Ken, and this time it wasn't a phone call. He actually got on a plane and came out to Palo Alto and spent the day with me. And we had a real Donnybrook where he formulated his new thing and all these various things. If there was a function that needed a variant of quad CT and a variant of quad IO and so forth, different positions in it would specify those values. And if there was it was the kind of function that had a variant implementation, you could provide that variant implementation and so forth. And the more I listened to him, the more I went, there's no way in hell I'm putting that in SACS. How are you going to specify this? Well, we could give them numbers. Well, if you give them the first 10 numbers, and the users can do their own. Well, if you give them the first 10 numbers, how does the user know when he can start using numbers that won't be eventually taken over by the implementation? And we went around and around, and one of his big arguments for me, and he'd actually prepared for this argument, I think, because he had Gene McDonald in the room. Well, it's always worked quite well for the circular functions. Yes, but everybody hates the circular functions because unless you've been working in APL for a while, how do you know what sine, cosine, tangent are? And much worse, how do you know which one's arcsine and which one's the other one? I mean, give me a break. That thing is a nightmare to use. That was me talking in front of my employee, Gene McDonald. And at the end of it, he shook my hand and thanked me for that thoroughly thought out argument. And he never did do any of those things. And every one of them are still in J, but not in the form J suggested to me. He's taken, I can't honestly say that I know Ken well enough to know whether he took my arguments into effect, but they had an effect whether he ended them or not. The way he looked at the problem changed from how he was looking at the problem when I was talking to him.
Yeah, I can see that here, that the dictionary APL has a more extensive use of it was called what was it called? Custom was what it is called there, and it's called.
I haven't read. I read the dictionary carefully for things I cared about, but I didn't read the whole dictionary. So
It's at the very end of it, the second to last section there, and it speaks about this, and it has things like so it uses the colon symbol for this, and which dialog, by the way, adapted as quad colon, and but only for system functions, never for primitives so far.
right.
So it uses things like circle colon 90. It sets the circle function to operate on a right angle of 90 instead of being right angle of half of pi system.
Got it.
That kind of thing, and apparently
Are you
more
talking
as well.
degrees versus radians? Is that kind of a switch?
Yeah, that's exactly what it's doing. And all similarly, instead of giving a left argument for format, it's using format colon something where like it moves the left argument of format into the variant thing, and and so on.
Like I say, he had all these great plans for it, and I really didn't. When APLSB introduced the notion of quad IO and all this, I thought, great, finally away from those stupid I-beams with a number as the left argument to tell you which one you're doing. And then after I'd used them for a while, I began to hate some of them. We hardly ever used quad IO when I was starting, and by the end, you could hardly write a function that didn't have quad IO in it, because if you wanted to write it one way and the user wanted to use it another way, you had to jump through all kinds of hoops to get things to work. So I was very pleased when Jay took the approach that several of us have been arguing for some time. Stop this nonsense. Let's just make the origin 0, and if anybody wants anything else, he can add one to the fucking number when he gets through. It's interesting. If you just talk to me, you'd think I'm a wild-eyed radical, and I guess from several perspectives I am. And yet I'm also very much a pragmatist. So for the years I was in charge of SACS and APL mainframe, not a one of these features ever made it into either platform. But that doesn't mean I don't have strong opinions about how programming should look and how you ought to use it. And that got me to thinking about a conversation you had in one of these meetings. Again, referring back to the talking about the source code. I think from time to time, to continue to grow, you have to have a second implementation, which just breaks some of the rules. The problem with that is having enough people that know both, that as a company, you can support both directions. I heard this in a conference years ago, and when I heard it, I thought it was over the top, but having worked now for nearly 50 years in the industry, I'm like, yeah, he was right. I think the saying goes something like, not convention, it's, well, the word is holding on to the past, but I'm forgetting the word, is the enemy of progress. And the fact is, it happens. There are things you were wrong, you want to fix them. I was so pleased when I spotted that Jay had turned around the arguments for encode and base.
Oh, so it doesn't transpose them anymore, you mean?
You don't need, yeah, it doesn't transpose them. And the whole reason for the transpose was a justifier that Jim Brown gave in his talk, which is complete BS, because all you had to do was turn the arguments around and it would work fine. Base works the way encode works I can't remember.
They're designed to match the inner product, because the inner product has a transpose
argument the wrong way around. If you turn the arguments around, you'd get the behavior I want and the behavior Jay has.
Wait, hold on. Turn the arguments around. What's the difference between
Inner
the
product does vectors on the left versus rows on the left versus columns on the right.
Yeah.
If you gave the left argument for base value as the
I see what you mean now. Yeah. I see what you mean. So the reason
I spotted that within days of them putting it in the system, because I had been working on an XM6 that didn't have it for anything except a scalar. In fact, I hadn't even noticed that it screwed up what a singleton ravel were. Somebody pointed that out the other day. I think it was the Jim Brown talk. But this was all based on the assumption that the arguments had to be in the same orientation that they are. Well, we change them around all the time for all kinds of things. Most of the principal operator contexts have the operator on the left, but divide by tradition has what you're dividing by on the right.
Yeah.
So we follow tradition.
I think that was wrong anyway. Division is backwards.
Well, it is. It's backwards from the idea of the whole tradition about how everything else works.
Yeah.
But
then it's inconsistent with the remainder.
Yes, exactly. There's all kinds of things like that they're just backwards. And I don't know, what is it, the jot diaresis?
Yeah.
That reverses the arguments in your APL, is that
correct?
that's
tilde diaresis, yeah.
Yeah, the jot tilde.
It's tilde with two dots on it.
Tilde diaresis. Tilde diaresis. Well, it's just tilde and J.
Yeah.
And initially it seemed like an affectation. I use it all the bloody time.
Yeah, me too.
It reduces tremendously the number of parentheses you need. And some things just read better. The way they put subscripting in, it's backwards from the way I'm used to talking about it in APL. So I use brace tilde because that way the arguments are in the sequence that I've thought of them for 20 years. So I don't have to rethink what I'm doing to figure out what the function's doing.
When you're talking about in J,
Yeah, J, it's got
APL also
the
has an
there's the
indexing function.
subscripting elements on the left and the data on the right.
Yeah,
So if you want to say data subscripted by, in fact, there's a lot of code in which you can read tilde as by. Data subscripted by, ta-da, is data variables, brace, tilde, subscripting elements.
Yeah.
In fact, I've got a whole, that's actually, I think, already online. I've got a whole table of my cheat sheet for how I learned J in the first 5 or so years after I experimented with it, where I refused to learn the vast majority of J and simply used it as a giant broken key APL. You know, oh, if I want to type this, I type this. And sure enough, after 4 or 5 years, I'd learned all the J I needed to know and almost never have to look back at my thing. But I do say almost because there's still a couple that I hardly ever use. And when I need to remember how those work, I go look at my cheat sheet.
yeah, it's interesting. I very much agree with you on the commute or
It's a hell of a
to
lot
the
more
data.
useful than I thought it was when I first saw it. I thought, why the hell are we putting that in the language? I could write that as my own bloody operator.
Oh, yeah.
Okay, so that's my work. Then I went off to serendipitously do something that I'd done as my first job at Trinity. I worked with a bunch of librarians at Dialogue, and every once in a while somebody in the community corrects me and says, no, it's spelled with a Y. No, it's not. You're not talking about the same company. And like I say, I began to get a little sense of J when STSC APL didn't work anymore. And then I'd had to write enough .NET code doing that job that after I retired, I tried writing my own. But a year into that, it was quite obvious I was the only one interested in learning about a compiled APL.
I don't think
So I
that's
did.
true anymore. Because there's a lot of young folks that that are very
Oh,
interested in that kind
we
of thing.
have begun to meet some folks at the Apple Bug thing. But
Okay.
in those early efforts, and then I'm probably not a very good salesman either. I'm too opinionated and too clear about what I think is good and bad. And they want to hear nothing but praise of the wonderful new feature.
Okay.
And so then after giving up on that, actually, I don't think the two are related at all. It's just that my son kept playing with my laptop, and games tend to melt laptops, at least the games he was playing. And that's also when, actually, I don't know exactly when Android tablets started becoming relatively inexpensive and readily available. But it was early there. It was 2012 or 13. I don't remember exactly when I bought one. And I haven't had a tablet since, a laptop since.
Oh,
I don't even have a keyboard. Part of it may be age. I find sitting, I use one occasionally. My kids both have them. But at my age, I find that I no longer touch type with the ease that I did years ago. And it's so much easier when I can just bring the keyboard up here and work. And then the other thing that's happened is writing things. I remember when Apple first introduced Palm Pilot or whatever it was called, and its ability to understand everything was atrocious. It didn't duplicate hardly anything you ever said. But I can write paragraphs of stuff using Google's voice analyzer, and
Oh, wow.
occasionally I have to change a word or so, but there's a lot of things for which I don't have to type at all. So I have been thinking about producing a workspace full of words so I could just say my program. I haven't done that yet. But anyway, that's why I got in touch with Nick when I heard about his work. And since he was kind of aiming in the direction of compiled code, there were two reasons attracting me to him. One, he was a guy who was trying to learn something in APL, and the barrier was so steep. There were so many things that you don't just pick up by learning the syntax. You have to know what the intention of those verbs are, and things like die, transpose, and pivot. A lot of those were just giving him grief trying to understand what the hell was going on. Plus, he was introducing me to things in dialogue that I just love. I was so glad to see Ken going away from that, and since I'd been using if then else for years, I was fine with that. But when I discovered that I could do all of this with nested brace notation and colon, I was like, holy shit, if then else was sitting there all the time and I never even saw it. So I consider dialogue's use of colon just fabulous. And if I'm correct, the way I don't think variables, the locals transmit on down with brace notation. Am I right?
Well, I mean, it, yes and no, as I mentioned before. They're lexically scoped. So that means if I'm a function and I define my own subfunction, then my subfunction can see my locals as globals to it.
But was the primary function written using brace notation as
Yeah,
well?
for now, just saying everything is using the brace notation of defense. Yes.
Okay.
But if I call some other outside function, it cannot see my things at all. It can only see its own definition stack up. That's what it means to be lexically scoped. It can see
I got it.
where
I
they
got it.
are defined.
I got it. Well, Jay's a little tougher than that. If it's local, the only people who can see it are the verb in which it's defined.
Yeah, but that includes the verbs that it itself defines, no?
No. If it defines a verb, that's a new verb, and it can't see.
Really? Oh, I didn't
Well,
realize that.
I haven't played with that extensively, so I'll take what you say and under advisement and do a little research. Yeah, because until recently we didn't have the brace notation. That's only less than a year old in the release. But
Wow.
even without brace notation, well, you could create a function inside the old notation, but you had to have access to source code and use you couldn't use the same technology because Ken never grasped the notion of having different open and closes around functions as a way of being able to properly nest things. Dell didn't do it, and the closing with right parens didn't do it. So there's if you try to just nest a function inside the original
That
J,
doesn't work.
it doesn't work. You're closing the outer one. But now that they've got braces, I'd have to try. But to my
I
knowledge,
just tried it right now. And in fact, it does that. I mean, J has this strange thing that if you have a name that's not defined, it's assumed to be a verb. So if you try to do like open double brace A, close double brace, and then A equal dot some 42. So you would expect that it goes on the right. So A gets assigned 42 in the outer function. And then that becomes the argument for the inner function, but the inner function ignores its argument and just tries to return A, and they will say, oh no, A is not defined. It must be a verb, but you can't return a verb from a function. So it will complain noun result was required. A, right? So it says A is not defined. So in
Got it.
fact, it cannot see that A is there.
That's what I expect from the rest of the behavior of J, is they just simply outlawed being able to see things.
But that's interesting.
But
If there's a global A, then it can see it.
It can see it until you'd make an assignment that makes it local.
Yeah,
And then at any further time in the functionality, not in the location. So if you entered a loop and A was a global, and then you assigned B a local value, and then you loop back up, the A you'd see on the line that used to be global would now be local.
yeah. Well, this is a bit
So-
interesting. Okay.
Yeah, it's very different than the way I did it in .NET and the way Nick did it in JavaScript, where no, we parse the bloody thing. The only way you can get really compiled code in J is this notion that I think is very valuable for simple things. It answers, for instance, the thing about between. Is this greater than equal to the argument and less than equal to the argument? That I love, that you can get two tests combined, this and that.
Oh, the
I-
tacit programming, you mean?
Yes.
The forks, yeah.
That's the one time when J compiles it, and if you go look at, they call them foreigns. If you go look at the foreign, that tells you how many times the verb got recompiled, the line got recompiled. It will only happen once if it's one of those.
Yeah,
And they even introduced a verb to help you write those things called 13.
yeah, no,
and-
define as tacit if it can, yeah.
Yeah, but I don't know who it was. It was somebody in your company said that there's a point at which it becomes irritating to read, and I agree.
Well, I think it was,
It's
Roger has been
fine.
saying that.
It's fine at 2 or 3, and I can kind of deal with it at 5, but beyond that, barf. I have to write the line as a comment above about what I started with, because I have no confidence that I'll be able to reconstruct what I was trying to do when I'm reading that kind of code.
Yeah.
So, I agree that I want the capability of having something, if it's used, particularly if it's used in the domain of what people call each, what we used to call dual disclose, or something like that, or
Yeah.
there's the non-disclose. There's the non-dual one. There's the one where you can open it, but you don't reclose it.
Well, let's in J, just composition.
Yes, composition and dual disclose. So if you're using those kind of things, it's useful to be able to have verbs in its domain that don't get recompiled every time, because they're doing the same work every time. Why they all have to be recompiled every time?
Yep.
But
Yep.
they only do it with that notation. There's no other full breadth. I can't use the whole strength of the language and not end up having to pay the price on every line in it every time it's executed.
That's true. We have it in dialog as well. Dialog has these tacit forks as well. So I think we probably should begin to round off, and
Yes,
this is the longest episode ever. But something you might want to look into if you're interested. There's a new language, called BQN, that Marshall Lochbaum, who's a former employee of Dialog, has, and who was a close student of Henry Rich, like studied off with Jay when he was quite young, and he's been continuing that work, something he started otherwise at Dialogue.
That's BQN.
Yeah, BQN, as in like you take the letters APL and increment them, and then
Oh, cute. Oh, I didn't even notice that. That's wonderful.
so and so he's taking a lot of things there and some conclusions made from experience with J and APL and mistakes that, as you say, there's some mistakes that you sometimes you need to make breaking changes to for evolution's sake. And there also an important thing is that BQN it can be statically parsed and therefore and compiled properly as well.
It's
Including
not
some,
necessary for everything, but there really are problems for which it's important.
yeah, that's true.
I don't personally have any of them anymore.
Yeah.
In fact,
Another aspect of it is that it's
my machines have either 4 or 6 gigabytes of memory. They've got CPUs that can run rings around the mainframes I used. And I actually looked it up recently, and the upload over my personal network is roughly 6 times as fast as a T1. No, twice as fast as a T1. And my downloads, some ludicrous number, like 12 times as fast as a T3. So we used to work whole communities of users at Dallas with far less bandwidth than I've got for my own personal stuff. So if it involves communication or it involves memory or it involves a fast CPU, what do I need help with? I've paid $500 or $600 for a tablet that blows everything I've ever worked on commercially away. So what would I care about performance? But I've certainly worked at companies where the amount of data we were dealing with, was in the tens of terabytes. And then the equation gets a little tighter. And I really do care about how you structure the data and how you approach solving it. But for what I do for my own personal self, even when I'm thinking of ludicrously large numbers, just to test how good the performance of this approach is versus that, I never bump up into limits like I used to when I was first introduced to APL. When I was bumping into limits all the time at whatever it was, 36K workspaces or something.
so Rory has put a link to BQN in the chat. You can have a look at that if you want.
Will do. Thank you for the reference, and thank you for your pleasant willingness to listen to me. I don't know that we've got anybody else staying on by this long.
No, we have plenty of people who are still listening, and I'm sure there'll be plenty more that will be watching the recording later. So no, absolutely fascinating. And as you unfortunately mentioned about your memory beginning to lack and names and so on, that this is why I want to record all this, because otherwise all this history will disappear.
We've lost a lot of friends. Gene McDonald, Ken Iverson, Roger Moore. I mean, a lot of the people that I got to know really well, they're no longer around to give us any data on what happened.
Exactly. That's why I really appreciate you coming, Paul. I mean, this is every fourth Sunday, and even if you aren't the featured guest, although you might actually have enough war stories that you could come as a guest again to tell more of them, feel free to stop by. And it often happens that people chip in with little side stories on what's being spoken about. So absolutely feel free to come.
Thank you, sir. Appreciate it.
Okay, then I'll say thank you to everybody and all the best.
Yes, everyone.
See you in 4 weeks.
Indeed. Bye-bye.